Yep. Okay. Today we are going to cover applications of some addition, some subtraction formulas, trigonometric identities. And we are going to apply to a sinusoid, correct? This is what we are going to be doing, is a sinusoid. A sinusoid, right, is something that is similar to the sine function, correct? So the sine function is, you plot the thing, is something like this, correct? That's a sinusoid. That's a sinusoid, something like it's like the sine function. Something different than a sinusoid, for instance, something like this. See, this is not a sinusoid. This is not a sinusoid. The sinusoid has to be something soft like this one. So those are the sinusoids, right? And we are going to analyze them today. And we're going to find equations for the sinusoid. It's very easy. So this class is not going to take more than 30 minutes, really. So let me just begin with sharing a graph in Desmos. Let me see right here. Oh my gosh, Desmos right here. Where is Desmos? Oh. Here, okay. Can you see the screen? This screen, this graphing screen? Yep. No? All right. Again, this is the screen I want to share. It's Desmos. You are familiar with Desmos. Okay. What I'm going to do in Desmos is very simple. I'm going to plot the function sine x, correct? So the function sine x is this, exactly what I sketched, is from negative infinity to positive infinity, goes from 1 to negative 1, and it's always the same. It's periodic, you see? Repeat this wave again here, and this repeats again and again. So it's a periodic function because it repeats the same pattern every certain interval. So in this case is negative 2 pi or 2 pi, you see? Every 2 pi repeats. Not a big deal, we know that function. Okay. Nobody else? Okay. Suppose now that, as you did with other functions, you multiply sine x by a constant. So you do this. So you are going to multiply a constant a times sine x. So what is going to happen? It's very simple. You see, here a is 1. Yeah, here is 1. And you see the new line. This is a blue line, is on the red line. Okay, what happens if I change, for instance, the a? For instance, I make the a equals 2. You see that the sinusoid stretches and grows, correct? What if I do a 3? Oh, if I do a 3, continues growing, you see, it's a wider, or it's a higher function, right? Same if I do 4, 5. So the number at the front of the sign enlarge the amplitude. This is going to be known as the amplitude. What happens if I do a 0? Well, I flat the curve, you see? I'm going to flat the sign. And if I go to the negatives, I'm going to flip over the function. So this is for negative 1, you see? So the blue is the negative of the red. When the red is positive, this is negative. When the red is negative, this is positive. So the blue is the negative of the red. And if I go for larger negative numbers, so it's going to be also flip over, but the frequency is going to increase. So A is the frequency, is the amplitude, really, is the amplitude of the sine function, correct? So not a big deal. Let me just know somebody else is waiting. No, nobody else is waiting. So I'm going to go back to the screen. Okay, so I'm going to disappear this one now. I'm going to put this in 1 just for the next problems. And then I'm going now to do the constant, but with the x. So I'm going to put the constant here inside the x. So here I'm going to put a new function. So I'm going to put sine of b times x. So it's going to be a different function, a different constant. So I'm going to put a slider to change the value of b. You know, Desmos is able to do that. And if you see this purple function right here is exactly overlapping this one. What is going to happen if I increase the value of b, for instance, 2? Oh, you can see what happened. The red line is my original sine function, and the new function repeats more frequently. When this red function goes once, you see one cycle, the purple function is doing 2 cycles because this number is 2. What about if I do 3? So if I change this to 3, you see, now, while the red function, the original sine function, goes one cycle, right? Yeah. The purple one goes 1, 2, 3 cycles. So this is going to be the frequency, how frequent this function repeats. So this is frequency 3 because this repeats 3 times as the original repeats 1, correct? What happens if I do 0? Okay, let me just say what happens when I do 0. So the function begins to enlarge, you see, and begins to get flat. So for instance, for 0.5, you see, let me just put here a 0.5, oops. Let me just put here a 0.5, right? So while the red repeats once in 0 to pi, the purple repeats just half. So this is half the value of 1, so this repeats half. If I make this one, if I make this one a 0, I flattens the curve, you see again. And when I make it negative, I'm going again to flip over my function. So in 1, for -1, for this frequency, -1, this is the negative of the original 1. And if I increases to -2, so it's going to happen the same as before, except that now this is flipped over, but it's going to repeat twice while the red repeats 1. So this is 1 cycle. This one is going to have 2 cycles, but inverted than for +2. Okay, let's see just the third constant I want to analyze, right? Is what happens if I add a constant here inside, x plus z inside the parentheses. So let me just do that. So I have sine x plus z. I add another slider, and now you can see that, let me just begin for 0. So when the c is 0, these two lines overlap perfectly well. As I increase this positive, for instance, 1, the line begins to shift to the left. You learn this in the functions that if you shift this function, you increase a positive, the function shifts to the left, you see? Is going to overlap every 2 pi, yeah? And if you make it negative, right, it is going to shift to the right, you see that one? You are not unfamiliar with this behavior. You have done this before, you have analyzed this in the functions you learn in Algebra 2, okay? So it's pretty much what is going to happen, correct? So is all these changes with these variables are sinusoids because are reproductions of this function right here. Now, the sinusoid is going to have this expression. Let me just show you. Oh. The sinusoid is going to be something like this. It's going to be y equals a sine bx plus c. So this is the general formula for a sinusoid. Now let me just put this one exactly in Desmos. So I'm going to Desmos again, right? Yep, I go to Desmos again, and I'm going to plug in right here, sine, well, a times sine, parentheses, b times x plus z, correct? So that's my function. So this new one is also overlap in the red. Let me just remove these two right here, these three right here. So the only we have is the red one and the purple. So if I increase the A, it's going to happen the same as before. You see, the amplitude increases when this is positive, and when this is 0, flattens, and when this becomes negative, reflects. Becomes negative, the upside down of the original one. So that's the same one, right? Okay. What happened when I do B, this B with the X? So I increase the frequency. You see, I repeat this function more times as the red. So while the red is just one cycle, this could be 3. You see, 1, 2, 3. Same if this is the negative. Yeah. You invert the function. Now, what happened when you use this one? It's okay. The same as before. You increase the X, make positive, shifts to the left. You decrease the constant, becomes negative, goes to the right. So pretty much this summarizes these three behaviors I did before. Now, here is the point I'm going to do. In your assignment, you see your assignment here. Oh, let me see. Let me just increase it and stop sharing. So if you see your assignment, well, I don't have it here, but you see the assignment we have to do today is this one, 5.308 is in your Google Classroom. You're going to see these combinations of sines and cosines. So let me just put here in blue, y equals 3 sine x plus 5 cosine x. Okay, this is a sine plus a cosine with 3 and a 5 in front. So what is the graph of this? How is this graph? Which is, well, I'm going to put this one in Desmos also, right? So I'm going to open Desmos. So I'm going to erase this one, and I'm going to put right here 3 times sine x, right, plus 5 times cosine of x, of x, correct? So you see, this has the same shape as this one originally, you see, like the red one. This black is a sinusoid. So what I'm going to do is I'm going to find A, B, and C such that this function reproduces this separated sine plus cosine. So let me just click this one. So I'm going to take this. This is the function A sine bx plus c. So I'm going to manipulate the sliders, correct? Such that I'm going to try to match the black line. So let me just begin the frequency. This is okay. Looks like pretty much like that. A little bit more possibly, right? Yep, possibly a little bit more. 9. Oh, already 9 right here. Yep. And let me now use the frequencies. Well, the frequency is not going to match very much. So I'm going to leave it like 1. And now let me just use this one. And then you see, if I increment z, let me just put it in 0, right? Yeah, in 0. And now I'm going to shift to the right, or possibly I shift to the left. So such that I overlap the thing. So you see that pretty much I overlap the thing. So possibly the frequency is a little bit high, or the amplitude is high, so that's much better. And this one, 0.1, 0.5, no, 5.2, 5.3. So it's a number between 5.3 and 5.2, you see? Pretty much like that. You see that? Okay. So this is with Desmos. So if you manipulate this expression, you see that you can find A, B, and C such that is the same as this one. But we are going to do this algebraically. So this is going to be the point. So I'm going to find A, B, and C such that this is the same as this one. How am I going to do this? Okay, I'm going to use my identities. Why identity? These ones. You see? if you see, sine of A plus B is sine A cosine B, sine B cosine A. So looks like this one, you see? Looks like this. So what I'm going to do is try to match one expression like this with this one, and then use this one to find this one, okay? So let me just put in red my identity. So is y equals, no, is sine of u plus v, let me just change the variables, is going to be sine u cosine v, no, sine u cosine b times cosine b plus sine v cosine u. So this identity is something that we have given, yeah? So no problem with this. We're going to use it. Now, what I'm going to do is try to match right here. So let me just change for this argument. So it's going to be sine of bx plus z, right? So this is going to be, let me just put here a times sine b. So this is going to be a times parentheses, because I'm going to open this one. So it's going to be sine b of x, correct? Sine of b of x, because this is the u, so this is bx. So I'm going to put here sine bx times cosine of b, but in this case it's going to be c, so I'm going to put cosine c, plus sine b, so it's going to be the c, you see, equivalent. So sine c times cosine of bx. Let me just use the parentheses with this one, right? Cosine c, sine c, correct? And I close my big parentheses. Now what I'm going to do is this one, I'm going to distribute, so it's a, right? Sine, let me just put here, a cosine of z times sine bx. I'm going to put the constants right here at the front. I put this together. And this one with this one is going to be a sine c times cosine b of x. So I'm doing just basic algebra. So I have this formula. I'm going to apply this formula right here. So a times bxc. I open this using this formula like this, and then I distribute. Now, I'm going to match 1 to 1. So this is sine bx. Okay, well, sine bx, here is an x. So this goes with this one, right? This goes with this one. Okay, another color. Let me just use different colors here. Okay, I have here the cosine x, right? And I have here cosine bx, correct? If I match these two, right? This is okay, sine x is this one, and cosine x is this one, there is no way out. Comparing these two, I found that b has to be 1, correct? So to match this with this one, this sign with this sign, you see here x is just by itself, here is bx. So to make these two equals, b has to be 1, same this one. So b is 1. Okay, I have the first variable, b is 1. Right here, b is 1. Okay, now let me just now match the other parts. So I'm going to use now this wiggle line, this one. I'm going to match with these three, you see? Because I match this sign with this sign, this in front of the sign has to match the 3. And now, this other one, let me just use different color, oops, this brown. So this one is going to match this 5, you see? So what I'm going to do here is write a cosine c equals 5, yep, and a sine c equals 3. No, let me see. A cosine, this is 3, and this is the 5. Okay? Now, what is this? Let me just use another board. I'm going to use another board to put this, right? And what I have to do is very simple. So I have a system of equations. A cosine C equals 3. A sine Z equals 5. So I have this. I have a system of equations, correct? So I take this one and I have this one. Now, how do you solve this equation? This is, man, this looks crazy, right? You learn how to do 2x2 systems of equations because this is 1, 2 variables, 2 equations. But this is special. Now, remember your trigonometry. If sine squared plus cosine squared of any angle is 1, I'm going to use this identity right here. But I don't have squares, you see? But I can square this. So I can square my expression. So I have a squared cosine squared is 3 squared 9. So I square this one. So I square the a, square the cosine, square the 3. And then I square the second one. A squared sine squared c equals 5 squared, 25. Now what I'm going to do is I'm going to add them. So I'm going to do a squared cosine squared c plus a squared sine squared c equals 9 plus 25. And that is 34. So everybody see what happened? This is the equations I get comparing, matching term by term my formulas. I have to find A and C. So I know this identity, sine squared plus cosine squared is 1. So it's a way to eliminate these two, cosine and sine. So I square the first one, I square the second one, I add them, and then I'm going to do this. A squared cosine squared plus sine squared equals 34. Now I know this is 1. So this is a squared equals 34. And a is going to be positive, negative, the square root of 34. Now, whatever is the square root of 34, I'm going to keep it. But if you want, you can check this. Okay, let me see. The calculator, right? And I check calculator, so I have control square root of 34. Yep, press enter, 5.83. So this is positive, negative 5.83095. Let me just use all the digits. So using the calculator, I get this one. If you remember this, the number I put in Desmos was 5.8 something, correct? Okay, here is my. Now, but I have a problem. I have two values, positive and negative. Which one can be? Remember that the A is this one. So, and let me just go back to the other board. Here is the other board. So the A is outside. This expression is positive 3 and positive 5. So this that is outside this expression cannot be negative. So I'm going to do A equals, let me just use black, right? A equals positive 5.83095. Here is. Okay. I found B, I found A, and now the only I have to do is find Z. Okay, I'm going to use these equations to find Z. So in this case, I have, let me just use this portion of the board right here. So it's going to be A cosine Z equals 3, or is the same, is the square root of 34 cosine of Z equals 3. Now, cosine of Z equals 3 over the square root of 34. And Z is going to be the inverse, our cosine of 3 square root of 34, right? Let me just put this one, 34, like this. And, well, if we use the calculator, we are going to find simply this. Calculator. So we're going to control, it's trig. Trig is cosine. In this case, cosine is going to be this one, cosine -1, the same as our cosine. And I'm going to put here 3 divided by control square root of 34. Oh, right here. Control square root 34. And I press enter. Okay, if I get this strange thing, I control enter. And I get this is 1.03038. Okay. Now, you can also, let me just go back to my board. So you can also use a sine square root of 5 in the same. So also you can use this one here. So square root of 34 sine of c equals 5. And the c is going to be exactly the same. You can do that if you want, but it's the same. It says or this one. Okay, so I found my 3 numbers. So I'm going to finish right here. So y equals sine a sine of bx plus c is going to be y equals 5.83. Let me just round to decimals, right? Sine of 1x plus z 1.03. Now, this is going to be the equivalent for this function, right? So let me just write it here. So once I found this one, this is going to be equals 5.83 sine x plus 1.03. So is what I have to write. Y sine x plus 5 cosine x is going to be, let me just put it right here, 5.83 times sine x plus 103. Okay? So this is the equation of the sinusoid. It's a long process. Yes, it's a long process, but it's not that difficult. Okay, let me just solve a second one. Yep. So I have the next problem in my assignment right here. What is it? Oh, let me just right here. Okay. No, well, I don't have it here. Let me just put the assignment right here. So my next problem is this one. Oh, right here. So it's 4 sine minus 5 cosine. So let me just stop share here. So in my assignment, I have this problem. So my problem is going to be, yep, y equals 4 times the sine x minus 5 cosine x, correct? So this is the problem we are going to work now. This one right here. Here is. So I need to find, yeah, this is going to be equals a sine bx plus c, correct? So we're going to transform these two in one. Remember what is the thing. So this is okay. Y equals, well, no y, this is sine, a sine right here of bx plus c is going to be a sine bx, right? Well, in this case, this is a minus, so we can use the plus or the minus. It's the same, right? We can use a plus b or a minus b. Let me just continue with a plus b, right? Sine bx, let me just put here sine bx times cosine z plus a sine z times cosine bx. So you see, I expand this expression using my formula, this one. And well, what I'm going to do is simply, let me just change this one. This is a cosine c times sine bx, right? And now let me just match the expression. Okay, again, sine b, let's use the brown. Sine bx is going to be this one, right? And this one is going to be this one. So I'm going to match 1 to 1. Now, if we match these two with these two, we see again that the b has to be 1. So it's immediately, okay? To match these two with these two, the b has to be 1. There's no way out. Okay, now, what is next? Okay, the next one is I'm going to match this one with a 4. I'm going to match this one with a 5, right? This is 1 to 1. So I'm going to put here a cosine c equals 4, and I'm going to put here a sine c equals -5, correct? So this is a minus, so this is plus -5. So I match this one, right? Okay. Now what I'm going to do is exactly the same. This is if sine square plus cosine square is 1, so I'm going to square these ones and add them. So I'm going to have a square cosine square c equals 16. A square sine square of c equals -5 squared is 25. So I'm going to have a square cosine square plus a square sine square is going to be 16 plus 25, 41, correct? Then I'm going to continue. I'm going to factor the a, so a square equals sine square c plus cosine square c equals 41. This is 1 because this identity, so it's going to be a squared equals 45. So a equals a square root of 45. Let me just continue taking the positive because the first one here is positive, right? And this positive, possibly the c is going to be the negative. So a is the square root of 45. Now, we can use a calculator, right? Right? And if we use the calculator, let me see. Yeah, is this one? Is the square root of 45. Control square root of 45. Yep. 6.71. 6.71. Let me just put it like that. So using a calculator, that's the round answer, correct? Now, the only I have to do now is find the z. So okay, let me just try to find right here, this one, right? So all the negative, I can use any. So what I'm going to do simply is I'm going to take a square root of 45 times cosine c equals 4, right? And well, right here, let me just see, cosine c equals 4 over a square root of 45. Yeah. And I'm going to solve this equation. So I'm going to move to the right. So here is c equals cosine -1 of 4 over square root of 45. Exactly as my calculator do. Arc cosine is the same thing. Then, well, I'm going to use the calculator, right? Let me see. Right here. Okay, so I need 3 cosine -1, and I'm going to put 4 divided by the square root of 45, right? Enter. Okay, control enter again. This is 0.931, right? That is going to be my approach, correct? Now, here is a point that is going to give me some answers. So I can do also c equals sine -1, so I can use this equation, and then I can have -5 over square root of 45, right? So this is sine -1. And I'm going to use the calculator again. So control, this one, the calculator. So I'm going to use trig sine -1. So it's going to be -5 divided by the square root of 45. And I press enter. Okay, control enter. And you're going to see a different value. So it's going to be -841. Okay. Now, here is the point. Which one is going to be the one? With positive or with negative? Okay, let's see. So this is what I found. So I have z equals positive 931 or negative 0.841. I just put here negative 0.841. So which one of them is going to be the answer? So it's okay. We can do this by reasoning or by exploration. So here is the point. If you see this is minus, really this should be minus, correct? So because here, according with my formula, a minus b is this one, sine b minus this one. So, okay, I'm going to take the negative as this one. So I'm going to take the negative as the solution. Now let me just check just in case I did correctly. So I'm going to Desmos again. So I'm going to, let me just delete all these ones here. Well, not this one, this is at the slider, right? Let me just take this one, take this one, take this one out. And then I'm going to have this one, and here I'm going to put 4. And here -5. Then you're going to change this minus. So here is the sinusoid, you see? Okay, now let me just put here the numbers. I found the b is 1, so I keep this one. A is 6.71. 6.7, it's pretty much the same. And now let me just explore negative 8.41. Negative 8.4. Oops, it seems that it's not working. Let me see 9.31. 9.9, 9.6, 9.4. Wow, we have a problem. We didn't get what we were expecting. So some of these values we got here, you see, are not matching my graph. So what is the problem right here? Let me see. This is 4, -5, yeah. A cosine z, 4 over the square root of 45. Oh, that's the problem. I put 45, not 41. This is 41 right here. Oops, sorry about it. 41, 41. So this changed a little bit of things. Let me just put it right here. 41, 41, and 41. That's why. Okay, let me just make the correction. I just was not paying too much attention, so I put a 45 instead of 41. Okay, so let me just change this one. So is square root again. So let me just take this one, square root of 41. .4, well, that doesn't change too much, it's 6.4, right? And, well, let me just now get this one. Let me just use the sign, enter, and put here a 41, right? Press enter, and I get 896, okay. 896, and let me see now the cosine. Let me just try to get the cosine back, right here, cosine, enter, let me just 41, and then press enter, and you see it's exactly the same number but positive. So it's positive 896. So my numbers change, right? So my numbers are 6.4, and 896, right? 896, 896. And then I'm going to check again in Desmos my numbers. So you can do the same to check if you are right. So it's 6.7, now 6.4. Let me just change the amplitude, 6.4. Okay, looks better. And then I have 0.986. Well, 6. No, this one is a 6.4. And now this is 0.896. 8. Let me see again. Stop share. This is positive. Let me check the negative. There is. You see? 8, 9 is almost 0.9. Yep, there is. So my solution really, yeah, is with a negative because we have a negative right here and the identity identifies with a negative. So this is the one. So my solution is going to be 6.4 sine x minus 0.896. That's the solution of my problem. Okay? So everybody catch the idea? It's a little bit guess and check, but we have to use this identity, these identities with sine squared plus cosine squared equals 1, solve a system, find the numbers, and match the solution. We can use Desmos, correct? It's very simple. Okay, any question right here? Difficult? Not very much? Okay. For homework, well, here is the homework. Let me just open that one. So I have here. So let me just try to find this file. So let me just open the file only. Right, teaching here 5 is this one. Okay, here is the file. Here is your homework, you see. Express the next functions as a sinusoid in the form y equals sine bx plus c. Round your answers to 3 decimals, so I did it 2, but you can do by 3. Use a calculator that can be the Desmos, right? You have here Desmos. You know that you have the graphing calculator, or you have the a scientific calculator. And then you do exactly what I did here. So you have 4 problems. And then on Thursday, we can check what about these problems, okay? So no question.